Hello guys, welcome to any tutorials, and today I'm gonna show you that how you can make a power supply that converts 220 volt AC to 0 to 15 volt VC variable and 12 volt DC stable. So I'm gonna transform this 220 volt AC both into AC and DC. So let's start, and I'm gonna make a layout for the circuit. So what do we need? We just need a 220 volt AC supply. This is our 220 volt AC supply, which we have to convert, and which will give us almost 220 volt RMS value. So now we will step down it by using our transformer. Now this is the AC voltage that we are getting from the main lines, and we have to convert this by just plugging in the switch. So this transformer will, I have made a step down transformer which will give 220 volts to 15 volts or 16 volts AC. So this is our 220 volts being converted to 15 volts AC. Now what we have to do for our convenience, we will just place a resistor and an LED, which will just show us that either the input is being applied or not. And then further we will just place an SPST switch and again a resistor and an LED. So this switch, this SPST switch, this is basically our enable switch, for which the power supply can be turned off and on. Okay, now what are we gonna do? I'm just okay, now let's place a fuse over here too. As you know that this is AC supply, so it can be dangerous for both you and your circuit. For example, if the circuit exceeds 220 volt, the 15 volts will also increase and it will burn out the circuit. So therefore we just have to adjust fuse so that it burns out and protects the circuit. Now this is our, now we are getting a 15 volts over here. Now what am I gonna do? I'm just gonna place a potentiometer. Let's say that this is our potentiometer. Okay, now I'm just gonna as you know that the potentiometer has three connections. One is for the output, one is for the ground, and one is for the input. Now I'm gonna connect this. Suppose this is a positive terminal, but there is no positive terminal AC, it just remains random. So we'll just connect it with our potentiometer, and we will connect this with a ground. So we have got this is a variable. Now we can adjust, it is a 1k ohm potentiometer, 1k ohm potentiometer, which will give us variable voltage between 15 volts and 0 volts. This is the ground. Now this is our this is our 0 to 15 volts AC supply. Okay, now we've got AC supply. Now we will turn our turn towards DC supply. Let's take another parallel connection for the DC supply. Now what am I going to do? I'm gonna place a capacitor, a regulator, and an HVDC rectifier in the series and in parallel, so that we can get a DC supply. So I will just place a rectifier to convert this AC into DC. So as you all know the symbol for the rectifier, so I'm just gonna make a rectifier over here. So I'm just gonna connect these two terminals, and I'm also gonna connect this terminal, which is our supposedly ground, so that before this portion we have, this is our AC portion, and now we will get our DC portion. This is our converted DC supply. So what will we do? Now we will connect these terminals to a 7812 regulator. So as you all know, regulator also has three terminals. This will be our input, this will be our supposedly ground, and this is our 12 volts. This is our ground, and this is our positive terminal. This is positive, this is ground, and this is our input. Okay, now what we have there 12 volt DC, and this is our 7812 regulator, LM7812. Okay, now we have got this 12 volt, but this 12 volt is pulsating and have a variable switch between the 0 to 12 volts. So we will just place a capacitor, and this we will place a capacitor so that it gives us a stable value. Suppose this is a 100 microfarad capacitor. This capacitor will give us a stable value, because if you will not use this capacitor, this voltage will fluctuate and it can burn or damage our device. So finally, this is our DC, and now let's move to the practical work.
I have made a power supply, and through the same layout that I have shown you before in the Proteus. Now let's test it. First of all, we will test the output of AC voltages. You can see that there are two connections, two wires for AC voltage, which will vary from 0 to 14 volts. First of all, we will connect the AC output with a DMM. As you can see that there is 16 volts at the output of AC voltage. Now when we will change the value of potentiometer, the AC voltage starts to drop, and when I'll just adjust it at the minimum, it will give 0 volts. It means that the AC voltage is variable between 0 to maximum of 15.3 volts, which is given as the variable value. Now we will test the DC voltage. There is no potentiometer in series or in parallel with the DC voltage, so it will just give us a stable value, which will be 12.26 volt, nearer to 12 volts. Now this was the complete layout of a Proteus power supply, which is given us 220 volts of AC and converted into 0 to 14 volts of AC and 12 volts of stable DC.